And some of the examples you'll see on homework will have some variables in them. Sometimes the variables can be rooted and released, and sometimes it leaves behind a square root of x. That's fine. Square root of x and square root of x are like radicals. So whether your radical is like square root of 5 and square root of 5, that's fine. Square root of x, I'll just give some coefficients too. So let's say this negative 4 square root of, those are like radicals. Okay. Those are like radicals. Doesn't matter whether the radicand is a variable or a number. It doesn't matter whether it's both. So we got negative square root of 2x and negative 9 square root of 2x. Doesn't matter if your radicand is a number, a variable, or a mix. You root out what you can, root and release what you can, whatever's left, whether it's a variable or a number or a mix, is what your radicand is. And as long as the radicand matches, if I added these, it would be negative 10 square root of 2x. If I added these, it would be 4 square root of x. This would be negative 3 square root of 5. As long as the radicand and the index match, you're good. You also see a couple on homework that may have cube roots instead of square roots. As long as the indices match, it's a like radical. But as you simplify, if it's a cube root, you've got to simplify with perfect cubes rather than perfect squares. So it's the same simplification process for squares and cubes. And whether there's just numbers or whether there's variables, same simplification process. So you might encounter some that look a little bit different on homework, but it's the same set of rules. Same things we've already been doing to simplify. Now just after we simplify, we're going to be adding or subtracting if we end up with like radicals. Okay with that? So in the last 15 minutes, I just want to introduce multiplication. We are just a little behind the schedule, not enough to throw off the test, but it means we'll be moving a little faster on Thursday, so make sure you get as far in the homework as you can. If that means starting to attempt the multiplication, that's really key. That's a really good idea. Okay. So let me just introduce the multiplication with a couple of examples. Now again, this is something I wrote out in my morning class. I'm not going to rewrite it out now. I'm going to show you, but don't worry, I'm going to sort of make a handout of it, and we're going to start Thursday with it. So don't worry about scribbling all of this down. Okay? You'll see it scanned in, and actually I'm probably going to make, like I said, make it into a handout for Thursday as well. Okay? So the rules for multiplying radicals, just like I mentioned about adding and all of that, we are using the rules of real numbers. The rules that you already know are the rules we're still using. Those rules haven't changed. They're just going to look a little different because we're dealing with radicals instead of x's and y's. Right? Or x and y's, sure, but they're all now we've got radicals involved too. So it can really mess with your brain. But keep in mind, remember, trust me, you are using the same rules you already know how to use. So, for example, in multiplying radicals, which is the second half of 11.4, multiplying radicals, you're going to be using the same rules you already know. For example, multiplying. Now these are just multiplying terms. We already know how to do this. 3x times 5x, product rule, multiply the coefficients, and add the exponents of like bases. Well, if we had 3 times the square root of 2 times 5 times the square root of 3, we could multiply that as well. And then we'd multiply the coefficients, and then the radicals, we use our product rule and put our two, multiply our radicands under one house. But it's the same idea. We are already used to distributing. Distribute a term times a binomial or trinomial, something else. That means we multiply that outside term times this plus that outside term times that. So 2x times 5x is 10x squared. Our exponent rules become involved. Plus 2x times 8, 16x. Now, hopefully, as we got more and more comfortable with that, we sort of we understand distribution sort of automatically, and we tend to do it like mentally. We can write down 10x squared plus 16x. Now, it's going to mess with our brains when we see the same setup when we try and distribute radicals. It's still the same rule of distribution, but I'm going to encourage you, as you'll see in the example we're about to do, to go ahead and write down that in-between step of this times that plus this times that. Because at first, if you try and do it all mentally like you're already doing with terms, it can really mess with your brain. Okay, you'll think, oh my God, this is something totally foreign. No, you know the rule. I'm just going to have you, until you're totally comfortable, write down that in-between step, and you'll see it's the same rules you already know. Okay. We'll also be foiling. Here, if you're foiling two binomials, no radicals, but still foil. First terms, using our exponent rules as necessary. X times x is x squared. outside terms, inside terms, and last terms. And if we have any like terms, we combine them. Same thing if we end up with, like, when we FOIL two binomials that have radicals, we end up with any like radicals, we combine them. If we multiply any radical times itself, we know that that obliterates the radical. Okay? So if our first term here was square root of 5 times square root of 5, we would end up with 5. Okay? Square root of 5 squared, which then would simplify to 5. Okay? So some of those new understanding of radicals comes in, but the basic FOIL setup is the same. Now, these are where these patterns come in, as this is why I encourage you so strongly when we're working with factoring, is to not ignore these patterns, okay? Because they're going to come back in other contexts here and more and more and more, and if you're not comfortable with these patterns, you're going to really slow yourself down, and in some cases really put a block up, a wall up in front of other concepts you use this for. A binomial squared means a binomial times itself. This means x plus 3 times x plus 3. Now you can write that out and FOIL it, but that really slows you down. And it's going to make things really messy with radicals. So understanding that pattern, not really memorizing a formula, but thinking that as mental foiling, x plus 3 times x plus 3 means x times itself. And then it would be 3x plus 3x. That's always your a times your b doubled, because your o and your I are going to be the same thing, right? So that would be your 3x doubled. So it's whatever your a and your b are doubled, 2 times a times b. So it's your first term, your a squared, your a times your b doubled, and then the L in FOIL will be 3 times 3, or whatever that last term is, squared. Okay. So the pattern is the first term squared, plus or minus, depending on what this is, your AB doubled, and then plus, always plus, because it's either positive, positive, or negative, negative, always plus, your last term squared. A squared plus or minus 2AB plus B squared. Okay. And the more you can put it automatically into this, then these you can start to do mentally. Oh, x squared plus 3x doubled plus 6x plus this squared, 9. X squared plus 6x plus 9 without having to FOIL it out. And the more you're good with that, you can go straight from here to here. Okay. X squared plus 3x doubled, 6x plus 9. Done. Now with radicals, again, it can get really messy on the brain. So this in-between step, I strongly recommend you write it down. Okay? And then you just apply your radical understanding to simplify it. Conjugates, really useful tool here. Conjugates, remember, if you FOIL this, the O and the I, the middle terms cancel out. One's positive, one's negative. So you end up with, when you FOIL, when you multiply conjugates, you end up with a difference of squares. So the pattern is, you know the O and the I are canceling out. You've just got your first term squared, always minus because those are mixed signs, your last term squared. So this would be x squared minus 6 squared, because your O and your I canceled out automatically. If you write it out with FOIL, you'll see the middle terms cancel out. So I take my first term squared minus my last term squared. That's it, difference of squares. With radicals, you write out this in-between step, and you'll start to see how it just follows the same pattern. Okay? So let's look at a couple of distribution examples to get you started. Okay? And then we're going to focus more on that FOILing and the conjugates and the binomial squared next time. But the further you can go ahead and try those in homework, the better you'll be prepared for that, because we're also going to start equations on Thursday as well. Okay, so let's do distribution, square root of 7, and then put up a parenthesis. We got a binomial of square root of 3 plus 3 square root of 2. And so when I say you're doing distribution with radicals, well, you've got, 3 different terms. One or more of them might be radicals. Okay? In this case, all 3 of them are radicals, but at least one is a radical. You still have to be wary of your radical rules. Now, distribution says multiply this times that plus multiply this times that. And without radicals, we really were doing that more mentally now. We would just go right to the answer. I encourage you to write this step out expanded until you're really, really confident. I still write them out a lot, most of them expanded, because otherwise my brain gets tangled up in the radicals. So this means square root of 7 times square root of 3. Okay? That's what this times this, plus this, square root of 7, times 3 square root of 2. Okay? So we're expanding our distribution. Now you can look at each little pocket and use your radical rules, your product rule of radicals, to combine things that you can. Now remember, you can only combine non-radicals with non-radicals and radicals with radicals. So our coefficients here are 1 and 1, so 1 times 1 is 1. Our coefficient's still 1. All we have are radicals here. So how can I write this? Yeah, product rule. Now, does the radical sign go away? No, not if you, only if your radicals or the radicands are the same. That's when you have a radical squared, boom, it blows up the radical sign. Not if you've got different radicands. This is just multiplied under one house, square root of 21. Plus, now here we've got, this is this times this times this. This is all multiplication. So look first at the non-radical numbers. What coefficients do we have? Yeah, we got 1 times 3. So that gives us a coefficient of 3. And now look at the radicals. Square root of 7 times square root of 2, and that gives you square root of 14. 7 times 2 under one house. And are these like radicals? No. Can they be simplified further?
No.
You always need to check. 21 is 1 times 21 or 3 times 7. Don't be intimidated to check with these smaller numbers. 1 times 21, 3 times 7. Are any of those perfect squares? Besides 1? No. So that's simple as it gets. If you don't have any perfect square factors, you walk away. 14 is just 1 times 14 and 2 times 7. Any perfect square factors in there? No. So it's done. You got to check, but these smaller ones, don't be intimidated to check. A lot of them just have 2 or 3 factor pairs at most. So, unlike radicals, you can't simplify them any further. That's it. See, your brain wants to see that and freeze and shut down. So trust me when I say these are rules you already know. So take a breath, be organized with your in-between expanding step, which you don't have to do anymore with regular terms for the most part, but go ahead and do that expanded step and you'll see, oh, that's something I already know how to do. Now this one's a little trickier, but just be organized about it. Square root of 5x, we've got variables involved now, times the binomial of square root of x plus square root of 5. Now first, write it out expanded. That times that plus that times that. Have you got any outside, look just at this first package, any outside coefficients? No, just ones, so. So, how can we write this?
5x. Square root of 5x.
5 times x squared, right. So, square under one house, 5x times x, which is 5x squared. 5 times x. Plus, this is both radicals, same index, so I could write this as
25x.
25x, yeah, multiplication 25 and a single x. 5 times x times 5, or 5 times 5 times x. Now, remember, I always need to simplify before I walk away, if possible. This whole thing is not a perfect square, but is any part of it a perfect square?
The 2x.
Yeah. So just to be extra expanded here, we've got a non-perfect square, which is 5, and we got a perfect square, so we have a leftover bit. Okay? So if I rewrite this with my x squared times 5, then I've got my square root, my perfect square, and then my leftover bit. So I can root and release the left, and that stays trapped. What about here? Perfect square? Perfect square? No. So perfect square on the left times leftover bit on the right. And then product rule lets me split them. So just like there's a 2 on the outside here, the 2's cancel out. The square root of x squared is x. Yeah. And, right, which is trapped, leftover bit. Right. Plus, right. Now don't let your brain be fooled by the 5's and the x's. Are these like radicals?
No.
Nope. Got square root of 5, square root of x. Doesn't matter that I got all these other x's and 5's. Not like radicals. That's done. So as you move forward as far as you can in the homework, then there's distribution, but you're going to also see ones where you have to FOIL, and just do your FOIL. Expand out that step. Don't try and do it mentally like you might do other regular foiling now. Write your 4 terms. You know, that times that, write it down. 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 And then see what you can, then simplify each term, and then see if there's any you can combine. All right? So the foiling with radicals can be the messiest one. But don't skip those in between steps. A lot of careless mistakes are made there. And think about these patterns for binomial, squared, and conjugates. And this is where we'll pick up on Thursday. And I will be down in the lab in 10 minutes. If you didn't get your test back, make sure and ask me.